Hi, Rick Crosslin here with another backyard science lesson. And this one has to do with one of the forces in the universe, electromagnetic energy. In fact, this electromagnetic energy is electricity. And I'm going to show you from my food I ate today, which was chemical stored energy that's been transformed into mechanical energy. And thanks to a British scientist named Michael Faraday, I can transfer that mechanical energy of a coil of wire inside of this magnet into electromagnetic or electricity, which will transfer, I think, to light, heat, and maybe some sound. Let's see what it looks like. Michael Faraday discovered this phenomena while studying magnets because magnetism and electricity are connected. That's why it's called electromagnetic. And you can make something called a simple circuit. You see, electricity or electrons flow in a circle. And without electricity, I couldn't move my arm. Our TVs wouldn't work, our cars, our lights. In fact, modern life would come to a stop without electricity. What is electricity? Well, it's the movement of electrons. And let's take a look at this here. Here I have a battery, and this battery is a 9-volt battery. Batteries come in different sizes, different shapes, and different voltage. And as Michael Faraday discovered, he also worked with an Italian scientist named Volta. And today, batteries are measured in volts in honor of Volta, who made one of the first batteries. So I have a 9-volt battery and a 1-volt battery. And this is stored chemical potential energy, meaning that when I hook up some circuits to it, we should see some transfer of energy. So I have here a little light bulb, and I'm going to hook it on this side right here. You might look close to it, and wow, complete the circuit. Open, close, open, close. And if I have a smaller battery that's only 1.5 volts, what do you think the brightness is going to be? The same as the 9? More? Less? Let's find out. Oh, take a close look at that. That little filament in there is just glowing. It kind of reminds me of the story of Thomas Edison, who spent hundreds and hundreds of different experiments to try to improve the light bulb to make a carbonized piece of string, a filament that would glow. So, 2 batteries, 2 sources of energy. But let's get back to circuit. And circuit kind of sounds like a circle, like you see right here. So I've made a drawing of a simple circuit. And if you know these symbols here for a path or a wire, a bulb, and that's a symbol for battery, then you know a secret language that scientists and electricians use to make circuits in your house, in your cars, in all your machines. So what we have here is a battery, and I'm going to use aluminum foil as my path because it's a good conductor. And I have a little bulb right here, and if I hook it right here onto that, wait a minute, nothing's happening. I need another piece of aluminum foil, and we'll use this piece of foil to finish connecting. I like to use a piece of tape, and tape is a good insulator. So I put the wire on top of the foil right about there and push it down, make a good connection. Put the wire on top of the foil right there and push it down. And now I have a switch that's open, and if I close it, we should see the light come on. Open, close, open, close. And you can make this at home. All you need is a battery, some aluminum foil, and a bulb. Open, close. I wonder what happened if I put 3 lights in a row. Are they going to be 3 times as bright, or the same, or less? Let's find out. So I'm going to tape that right here. And now we have 1, 2, 3, 4. Are they going to be brighter, the same, or less? Let's find out. Ready? Look at that. Now 9 volts is being shared by 4 light bulbs, and each one gets a little bit less. There's a lot you can do with this. Let's go back to 1, and it should be bright and nice. Nice. Okay, so, but this is one of my favorite circuits. That was a simple circuit turned into a series circuit, and this is a parallel. Let me show you how it works. So you notice it still has a source. There's my symbol, and it has a path. I'm going to tape this guy right here, aluminum to aluminum, but I have put a parallel line. And now I have these across a parallel, and let's see if they light up, and they do. This one is a little bit of here we go. And all three of them. The beauty of a parallel circuit is if you take one out, the others should still work. Let me take this middle one out and see what happens. And the others still work. Two safety concerns. One, I use batteries. A 1.5 or a 9 volt shouldn't be a problem. Never do these experiments by anything that's plugged in the wall. That's 110 volts coming from the generator plant that keeps sending a lot of volts. So be safe. Number two, don't short circuit across. You need a light bulb. Can you imagine what it was like when we first had lights in our homes and in our streets? It must have seemed like magic, where light would go from one place to the next, almost like a magic that goes from here to this hand here. Hey, have fun, learn the simple circuits.